Hey everyone, my name is Dev, and I'm a current computer science major at Vanderbilt University. Now, just thinking about it, my computer science background actually began all the way back in high school. And that's a similar spot that many of you may be in right now, where you're a high school student looking to gain exposure to computer science and learn a little bit more about programming as a whole. I know from my time back in high school that there weren't too many resources made available that would give you a foundation to build upon your programming skills or even give you exposure to computer science. And that's part of the reason why I'm so excited to work with GenCode as a platform that I can use to share my knowledge in computer science with all of you. I want to use this course as a way for me to help you build up your Java programming skills and eventually be able to write your own Java programs. So without further ado, let's get right into it. Before we go into Java's capabilities, what Java is, and some of the syntactical rules associated with Java, why don't we go over a little bit of background behind Java? Java is a programming language that was created by a guy named James Gosling. And at the time, he worked for a company called Sun Microsystems, which was then later acquired by Oracle. This helps explain why Java was originally licensed under Sun Microsystems, but then later it was licensed under Oracle. The language was first made publicly available in the year 1995, so it's been around for quite some time. Over its lifetime, Java has been continually enhanced and new versions are regularly released, with the latest version being Java 8. Also known as Java 1.8, it really depends on which source you're going to be looking at this information from. The creators of Java had one primary goal in mind. They wanted to be able to create a language in which you can write code once and then be able to easily run it across various domains and platforms. And Java enables you to do just that. A fun fact, actually, is that the creators of Java were very forward-thinking, and they were looking years and years into the future. Back in 1995, they had envisioned a language that you can use for everyday consumer appliances. Now looking at the year 2021, we have Samsung fridges with iPad-like displays that run code and provide extensive functionality beyond what you think a fridge should be capable of doing. I'm sure many of you have been able to see exactly which fridges I'm talking about. And that's just one example of a consumer appliance that uses some of this code. And in many cases, that's going to be Java code. So it's nice to see exactly where Java originated from and what people were thinking about back then that is translated into the technology of today. You might be thinking that if Java was created in the year 1995, then what relevance could it possibly have today? As in, who uses Java? To your surprise, actually, many major companies use Java as key components, and they use this to be able to build out core functionality in some of their products. Companies like Uber, Airbnb, Google, Pinterest, and Netflix, just to name a few, use Java to build out functionality within their products. So it's definitely a very popular language, and kudos to everyone who still maintains the language and makes it extremely usable for developers as the years go on. An interesting thing to note, however, is that we touched upon exactly what the goal of Java was as far as what the creators wanted to come from the language itself. What we didn't touch upon is what actually popularized the language. As Java began to build up more and more traction, it wasn't the machine independent of Java as a language that enabled more and more users to want to use Java as a platform. But rather, it was the core functionality with web development that Java provided developers, such as applets and other components, that really popularized the language as a whole. And for those of you who don't know exactly what an applet is, it's a small piece of code that the browser can use and the browser can run. So now that we've talked a little bit about Java, let's go into more depth on what some of the components of Java are. Like when you set up Java on your environment, what exactly are you going to have access to? You're going to have access to a programming language. In this case, it's Java. We've all established that at this point. And then you're going to have a compiler. And this won't make too much sense to you right now, but as we go further into the presentation, hopefully this is something that becomes less of a foreign concept. You're going to have inbuilt libraries. As we go deeper into this course, we're going to actually interact with some of these libraries, and you'll see exactly what I mean when I say that these libraries are super, super powerful. Finally, we're going to have something called a Java virtual machine. And again, as we go further into this presentation, I'm going to be sure to cover exactly what a Java virtual machine is and how it works and how you should understand it. Let's cover some of the core capabilities of Java. What makes Java so special? As I mentioned before, it's platform independent. And this means that you can write Java code on one machine and then easily be able to run it on other machines without having to recompile it. On the contrary, take a language like C++, for example. In order for you to be able to run it on a different machine, you would have to take that C++ code and then recompile it prior to you actually being able to run a C++ program. And that's what makes Java so special. Java is also an object-oriented language. And that means that at its core, everything in Java relates back to classes, methods, and instances of those classes, also known as objects. And this won't make too much sense right now, but I assure you, as we go deeper into the course, it's going to make more and more sense. So just stick with me and we'll get to everything that you need to know about object-oriented languages. Java is also strongly typed. And what that means is that when you want to define variables to store different types of data, you must specify the types of data that you want that variable to hold. And that's an important thing to know about Java, just because it helps keep things very nice, very organized. Java also has automatic memory management. And this is different from a language like C++, where you'd have to actually go in and manage some of the memory when you create your own instances of classes. Otherwise, the program would fail to run and it would lead to a whole slew of issues that I don't want to get into right now. And this automatic memory management component is going to make more sense when we talk about classes and objects. But for now, just at least familiarize yourself with that term. Java is also widely used and super well documented. It's a language that since 1995, many developers continue to use to this day just because of how well documented the language is. And it continually gets updated to incorporate new features that developers can take advantage of. And I think that's one thing to note about Java that's super special. If you want a language where it's widely supported, Java may just be the language for you. I want to take this time to talk about the life cycle of a Java program. Anytime I took a computer science course, the professors took time to explain exactly how the code that we're writing interacts with the hardware components of the computer. As in, how does the code that we write get interpreted by the computer? Because obviously computers don't understand languages the same way that we do. The code that you write in something called a text editor within an integrated development environment, or IDE, is known as the source code. And this source code is written in a language, let's call it, in our case, it's going to be Java. But this language is more similar to the human language than it is to a component that the computer can interpret itself. So in order for us to be able to take the source code and convert it into a form that the computer can understand, it's going to have to go under a series of transformations. And this source code is going to be fed into something called a compiler. And what this compiler does in Java is it takes the source code and converts it into what we call bytecode, which is machine independent, meaning that you can take that code and run it across multiple different platforms, and you won't have to recompile it in order for it to work with a machine. And in Java, bytecode and a source code file that's taken and put through a compiler is going to end up being something called a .class file, which is the bytecode for a Java program. And this bytecode still isn't in a format that the computer can understand, because computers understand only zeros and ones. So in order to get it to that format, what you have to convert it to is something called machine code, which is just a set of zeros and ones in a specific format that means a specific thing that the computer can interpret. To do this, the bytecode that we just talked about, the .class files, get fed into what we call the JVM. And the JVM is super useful because it'll go and then convert the bytecode into what we call machine code, the series of zeros and ones that can be interpreted by the computer. Now that we've covered all of that information, I think we should take some time to talk through exactly what's going to be covered in this course. Let me just give you a high-level overview of some of the different topics that I plan to touch upon in this course. We're going to go over types, operations, input and output, methods, decision and control structures, introduction to classes and objects, some of the useful libraries that Java has already inbuilt, and I might even show you how to write your own library as well, depending on exactly what level of engagement we get. But the last thing that we're going to cover is project ideas, and this is going to be a core component of this course because I want to be able to take whatever you guys learn in this course and then apply it to real-world applications and real-world projects, for you to really get some hands-on learning associated with your learning of Java. And finally, before we conclude this presentation, I'm going to go over some things that you're going to need for this course. You're going to need an IDE, and it won't make sense to you right now. Just hold off on that. That's something I'm going to show you exactly how to get when we do the environment setup in the next video. You're going to need Java. Again, you're going to get that information when we go over the environment setup in the next video. And then finally, you're going to need some excitement about computer science. And if you're here at this point, I know you have that much at a bare minimum. So with that, I'm going to conclude this video. Thank you all for watching. Excited to engage with you over the course of the next few videos. And if you have any questions, feel free to reach out. But that's going to conclude this video. Thank you.